Hello, this is my house. I am gonna film my video for you in my home. That's my cat. Say hi, Rigby. And this is my best friend, Kelsey. Hi. Kelsey is visiting from Denver. She's doing work. And now I'm gonna take you over to the kitchen where we are gonna set up this wonderful little contraption. I am going to balance my phone on a coffee mug and we are going to do the do now at the top of page 9. All right, so yes. All right, this is awesome. I love it. Okay, so in this video, I'm just gonna do the 5 do now problems. If you're feeling good with the do now problems, then you can skip over this video. And I'll do a separate video for the 3 problems that are at the bottom of page 9. But for now, getting into the do now. So this is just a little bit of a review of the stuff that we've already covered in terms of the exponent rules. So notice what you're asked to do. You're asked to simplify the following problems from the exponent packet. I don't know what the exponent packet is, but these problems are here, so we're gonna do them. All right, when we look at A, I'm seeing some negative exponents. I've got numerators, denominators, but the overarching operation that's happening here is multiplication. All right, so as I'm looking at this, I'm thinking, all right, I think this is probably gonna be a good candidate for PEMDAN. So remember, parentheses, exponents, multiplication, division, 0 exponents, and negatives. So the first thing I wanna do is just work inside the parentheses first. Is there anything I can do in this set? No. Is there anything I can do in this set? No. All right, so the P is taken care of. Can I apply any exponents? Well, yeah, I'm definitely seeing that I can apply this exponent inside this set of parentheses, and I can apply this exponent inside of this set of parentheses. Sorry guys, I just taught at the gym and I'm like kind of forgetting how to form words. I'm gonna distribute the exponent in here. So I've got m to the negative 2, m to the negative 2 over m cubed. All right, I'm gonna distribute the exponent in here as well. So I have 1 to the negative 3. I have m squared to the negative 3. So anytime I'm raising a power to a power, I multiply. So this is going to become m to the negative 6th. And then here, n to the negative 3 to the negative 3, again, power to a power, you're going to do n to the 9th. You're going to multiply. All right. Well, 1 to any power is just 1. So this kind of like disappears. It just becomes 1. And here I'm seeing that, all right, I can do a little bit of the green bean method because I've got 2 terms with common bases that are stacked one on top of the other. So m to the negative 2 over m cubed. Now thinking about this, negative 2 minus 3 would be m to the negative 5. That's multiplied by n to the negative 2. And here, this becomes 1, so I have 1 over m to the negative 6, n to the 9th. All right? Well, at this point, I've gotten rid of all of my exponents in terms of distributing them into the parentheses. So now I'm thinking maybe I should just multiply all this stuff together. I can put this over 1. I can multiply everything in the numerator, m to the negative 5, n to the negative 2. 1 times all this stuff, it doesn't change that denominator. And so now I'm thinking, all right, I've got to do some division. Well, again, green bean method. Stack the m's, stack the n's. Negative 5 minus negative 6, all right? That becomes plus a positive. Negative 5 plus 6, that becomes m to the 1st. And negative 2 minus 9, that becomes n to the negative 11. All right? Next step, you're looking for 0 exponents. I don't have any. Last step, look for negative exponents. I have to deal with that. So this is going to become m over n to the 11th. If you'd like to put a 1 there on the m as an exponent, you can, but it's not necessary. And that's your final answer for the first one. Moving to the next one, 27 over 8 raised to the power of negative 2/3. All right, so we talked about rational exponents here, and we said that rational exponents is essentially an exponent with a root. The denominator tells you the type of root that you're dealing with. So in our case, what we actually have is a cube root. And I'm going to change this right now. I'm going to make this the cube root of 27 over 8. Now you have choices. So your choices here are you can take that and raise the inside of the root to the negative 2, or I can do the cube root of 27 over 8 and then raise all that to the negative 2. So it's kind of your choice. Do you want the negative 2 to go on the stuff on the inside, or do you want the negative 2 to go on the entire expression with the root? My recommendation is actually to do it this way, because applying the cube root first to 27 and 8 is going to make those numbers smaller. And if we can make those numbers smaller first, it's going to be easier for us to do these calculations. So let's do it. Take the cube root of 27 and the cube root of 8. So the cube root of 27, the cube root of 8, and I will raise the result to the negative 2. Well, the cube root of 27 is 3, the cube root of 8 is 2, and I'm going to raise that all to the power of negative 2. I can apply the power to both numerator and denominator. This becomes 3 to the negative 2 over 2 to the negative 2. 3 to the negative 2 is 1 over 3 halves. 2 to the negative 2 is 1 over 2 halves. This is 1 over 9 over 1 over 4. This is 1/9 times 4 over 1. Remember, when you're dividing by a fraction, it's the same thing as, a little bit hard to see that, sorry. It's the same thing as multiplying by the reciprocal of just the denominator. And this is going to give us 4/9, final answer. Okay, I'm just going to pause the video right now because if you're getting a pretty good understanding of how to do the do now, I don't want you guys to suffer through more of this video. So I'll pause, I'll make a new one.